Let's balance the redox reaction BrO3- plus N2H4. And we're going to use the ion-electron method, also called the half reaction method. First thing we need to do is write the oxidation numbers for each element. And that's going to look like this. If you need help with oxidation numbers, there's a link at the end of this video and in the description. So once we have the oxidation numbers, now we're going to write the half reactions for the species of interest. These are the ones that have changed. That looks like this. So for the bromine, we went to +5 to -1. So we went to a smaller number. This has been reduced. We also lost oxygen, so that makes sense. And then the nitrogen went from a -2 to a 0. So this number got larger. -2 to 0, that gets larger. So this has been oxidized. So those are the half reactions here that we're dealing with. Now that we have these half reactions, we can balance each half reaction first for the atoms of interest. So here we have 1 bromine and 1 bromine. No problem. 2 nitrogens, 2 nitrogens. So those are already balanced. The atoms are balanced. Now we can deal with the oxygen atoms by adding water. This is taking place in water. So we have 3 oxygen atoms here. Let's add 3 water molecules over here in the products. So now we have 3 oxygens and 3 oxygens. Down here, there aren't any oxygens. Now we can balance the hydrogen atoms by adding hydrogen ions. This is an acidic medium, so we have hydrogen ions available. 3 times 2 is 6. Let's put 6 hydrogens over here. So we've balanced the hydrogen atoms. We'll add 4 hydrogen ions down here. Those are balanced. Now the charge. We balance the charge by adding electrons. So when I look at this, I have a negative and a negative. That's fine, but then I have the 6+. So I'm going to add 6 electrons here to balance that charge. Down here, I have a 4+. I'm going to add 4 electrons to balance that charge. So now charge is balanced. So now we're going to balance the overall reaction for electrons, and then we'll simplify. When we think about it, 6 goes into 12 twice, 4 goes into 12 3 times. So we can multiply this entire thing here by 2, and this entire half reaction here by 3. Now we'll have 12 electrons, 2 times 6, and 3 times 4, 12 electrons. The electrons would be balanced. Then we'd multiply everything here by 2, everything here by 3, and then we could write our overall reaction. After that, we simplify. To be clear, what we did is we multiplied 2 times the reactants and 3 times the reactants in this half reaction. So those are our reactants up here. And in the products, we have 2 times these here and 3 times these products here. That gives us our overall reaction. When we simplify, we cross out things that are the same on both sides. 12 electrons here, 12 electrons here, 12 hydrogen ions, 12 hydrogen ions. Everything else is unique. So this is the balanced redox reaction for BrO3- plus N2H4. Let me clean this up. We'll have our redox reaction. So as difficult as redox reactions are, you can always check if you have it correct. Here we have 2 times the 1 minus. That's 2 minus. Here we have 2 times 1 minus. 2 minus. Charges are equal on both sides, and if you count the atoms up, they're balanced too. So that's it. We're done. This is Dr. B with the balanced redox reaction for BrO3- plus N2H4. Thanks for watching.